Hello and welcome to lesson 4 of topic 28, inequalities. So over the last 3 lessons you've done the first 3 bullet points there. We're going to focus on the 4th one here. It's the idea of solving 2 inequalities, finding the solutions and then comparing them to see which values of x work for both inequalities. Okay? So you should have already ticked off those first 3 and we're going to work on the 4th one today. So that's your title, Solving and Satisfying 2 Linear Inequalities. Okay, only a couple of examples this time, but we'll look at them in a bit of depth. So this is the sort of question you would be required to solve. So finding the range of values of x that satisfy both this inequality and this inequality. So we're looking for some values of x that work for both of these inequalities. So the first thing we're looking to do is to solve them both individually. So if we look at this one, we'd be looking to expand the bracket first. And then solve that as you normally would do. So subtract 6 from both sides. Divide both sides by 3. And we've got a solution of x is less than or equal to 8. Now we're looking to do the same sort of thing with this one. So I would subtract 3 from both sides. And then divide both sides by 4. And we've got x is greater than 4.5. Okay, now at this point, we want to write down one set of solutions that work for both inequalities. So this one is saying that x is less than or equal to 8. Okay, this one is saying x is greater than or equal, just greater than 4.5. Now you can go straight to just putting those into one inequality, or if you wanted to, you can try and draw them quickly onto a number line and just see them visually. So if we put a few numbers on here, like that, what we're looking for this one is we're saying that x has got to be less than or equal to 8. Now we looked at how to display this in lesson 1, so something like that. This one's saying x is greater than 4.5. And so what we're looking for is the solutions that work for both of these inequalities. So really, we're looking in this area here. Okay, we're looking for that bit. So we're looking for the inequality that is greater than 4.5, but also less than or equal to 8. We're looking for this bit in the middle. So in terms of how to write that, I want to write that as one inequality. So I want to say that x needs to be greater than 4.5 and less than or equal to 8. Okay, that is the set of solutions which works for both of these inequalities. Okay, as soon as you get above 8, it doesn't work for this one. As soon as you get below 4.5, it doesn't work for this one. Okay, so it's just that overlap bit there. Okay? Right, so I'd like you to copy that down and just make a few notes. And you don't have to necessarily draw the diagram every time, but it sometimes helps to see it visually so you can try and understand where you're looking at. Okay? Right, so copy that down. Next example. Similar sort of style of question, but this one's been broken down into parts for us. So first part is just to solve an inequality like normal. So you're looking to subtract 6 from both sides. So we'd be saying 4x is greater than or equal to negative 4. And then divide both sides by 4. So x is greater than or equal to negative 1. So that would be the answer to A. For B, you're looking at the inequality displayed by that diagram. So we want to say x is, the arrow is going this way, so I'm looking for less than. It's an open circle, as we talked about in lesson 1, so I don't need equal to. So x is less than 3. So that's going to be your inequality for that answer. You're then looking to write down all the integers that satisfy both inequalities in part A and part B. So again, you can look at a diagram, and they've already drawn this one for us, so we may as well add to that. So on top of that, I'm looking for x is greater than or equal to negative 1. So we're looking at something like that. And so in terms of an inequality, I'm looking for this bit in the middle where they overlap. So I'm looking for x to be greater than or equal to negative 1 and less than 3. So that's my inequality. But I haven't finished the question because the question is saying write down all the integers. So now we're thinking back to lesson 3, where we looked at how to identify integers from an inequality like this. And we're looking for the whole numbers that work for this inequality. So we're looking at the numbers in between. And then we're looking to check the ends of the inequality. So we're looking at not 3, but it can be -1. And so that would be your answer to part C. And again, there's no expectation for you to do this bit. You don't even need to do this bit. Okay, you can just look at those 2 answers and think, what whole numbers do I know that are greater than or equal to -1, but less than 3? Okay, but for me, I would want a bit more working. I would want a bit more understanding. So I'd like you to copy this one down and try and add as many notes as you can in terms of why this answer appears. So as I say, it can be this, it can be this as well, but just try and explain why that is the answer that it is. Okay, any questions? Then please ask your teachers. Have a go at the questions in the booklet. And yeah, any questions, let your teachers know. All right, thank you.